Hello everyone, welcome back to Diksha Vedantu Foundation channel, and you are watching 99% in 99 days. So today is day 68. Obviously it's time for the sample paper 3 for the physics part of the paper to be solved. Obviously other parts, let me know if you have seen biology and chemistry solutions, and if you have received this question paper or not. The question paper is being shared in our WhatsApp channel regularly. Just before the we are going to release these videos, the question paper is available 1 day prior, so that you can download the question paper and check it for yourself, and whatever doubts you might have, that doubts can be clarified through our videos. And mention in the comment below if you faced any difficulty while solving sample paper 3. Right, now let's see the paper analysis. Paper analysis is a slightly older version of the question paper, where we used to get 20 MCQs, 5 assertion and reason paper. So here we have in this paper we have 4 MCQs from physics and 1 assertion and reason from physics, so total 5 1-marker question. And then we have 1 2-marker question, we have 3 3-marker question, and then we have 1 5-marker question, 1 4-marker question as usual. So total marks for physics as usual 25. Now let's see with the question. MCQs. A complete circuit is left on for several minutes, causing the connecting copper wire to become hot. As the temperature of the wire increases, the electrical resistance of the wire decreases, remains same, increases for some time, and then decreases. Okay, many students will be tempted for the option D because it's a long answer. Okay, you have to remember that it is long is not always the correct. So as the temperature increases, the resistance of a conductor increases. As the temperature increases, resistance of certain material called semiconductor, their resistance decreases. But that will be in a next class 12th. So for now, all material, all the resistance, because copper is a conducting wire, so they will not give you semiconductor definitely. So copper is a conducting wire, copper is a conducting material, conducting metal, it's a metal. So basically when temperature increases, its resistance will increase. It's directly proportional to the resistance. Temperature and resistance are directly proportional. My mistake. So I hope this question number 13. Now let's move on to the question number 14. So this is a very interesting question. While seeing this question, I was surprised to see that they have given a little bit tricky question. Generally, if the question paper is little hard, then this kind of question is expected. Okay, a copper wire is held between the poles of a magnet. The current in the wire can be reversed. The pole of the magnet can also be changed over. In how many of the 4 directions shown in the can the force act on the wire? So what is the meaning of that? So here they have shown some current carrying conductor. Okay, and suppose the current in this case is flowing in this direction, suppose. Okay, now we have to apply the Fleming's left hand rule to find the force on the conductor, right? So Fleming's left hand rule says that this is the direction of magnetic field, this is the direction of current, this is the force acting on the conductor. So it will experience a force downward direction, right? Now similarly, if you change the direction of current, now suppose the direction of current is now changed to the opposite side. Okay, so now the current is flowing in this direction. Now in this case what will happen? Now the wire will experience a force in the upward direction. So first case it was downward direction, in the next case it was upward direction. Similarly, if you change the magnetic pole as well, magnetic field, if you swap the poles, now this is north, this is south. Now if you swap it, this will be south, this will be north, this will be south. So magnetic field direction will be also changed. Okay, my initial direction was wrong, it will be south to north. So based on the relative orientation, you can change the direction as well. So initially I was wrong, sorry, my mistake. But basically what is my point is, no matter what you do, if you change the direction of current as well as orientation, then it will remain same. Okay, if you just change the direction of current, it will be opposite in the downward direction. If you keep the current same, if you reverse the polarity of the magnet, it will be in the downward direction. So only north or south is possible. So only the force that is experienced by the wire can act only along north or only along south. It will not have any component, any force on the east-west direction. So only 2 is the answer. So it can experience force only in 2 directions, either in north direction or in the south direction. East-west direction, because the magnetic field lines are in this direction, okay, there will be no force along east-west direction, right? Now let's move on to the next question. Another interesting question. Plastic insulation surrounds a wire having diameter D and length L as shown in the above. A decrease in the resistance. So very important, a decrease in the resistance of the wire would be produced by an increase in the. So how can you decrease the resistance by increasing something? Only thing that can be increased to decrease the resistance is the area. Only thing, because we know that R is equal to rho L by A. Okay, so only thing you can decrease resistance. So resistance is decreasing only if you increase the area. Now what is area? Area is pi R square or pi D by 2 whole square, right? This is the formula for area. So how you can increase the area? To increase the area you have to increase the D, right? So only by increasing the diameter you can decrease the resistance. So diameter of the wire has to be increased. So by increase in the diameter of the wire. Okay, you have to complete the sentence. So diameter of the wire is the correct answer. All other options are not correct. Now let's see the other question. Which of the following pattern correctly describes the magnetic field around a long straight wire carrying current? So long straight wire carrying current will have a magnetic field like this, right? Concentric circles, we know already. These are already know, we are super good, right? All of you are super good. They are already studied this, right? Circular magnetic field lines around a current carrying coil. So it will be concentric circles centered around the wire. Concentric circles centered around the wire, right? So this is the center, concentric circles. At any point you can take, okay, they all will be concentric circles, right? So for a straight current carrying wire, magnetic field lines will be concentric circles centered around the wire. Next question, this is an assertion reason question. On a freely suspending current carrying solenoid, it comes to rest in geographical north-south direction. So if you have a solenoid, okay, and you have connected it to a battery, and if you freely suspend it using some mechanism, okay, after coming to rest, it generally points in the north and south direction. Okay, very interesting. Why so? Let's see the reason. What the reason they have given? Is it correct? Yes, it is correct. We know that a solenoid behaves like a magnet. We have seen the magnetic field lines of the solenoid, so definitely it will point towards the north-south direction, right? So one end of the current carrying straight solenoid behaves as north pole, on the other end as south pole, just like a bar magnet. Yes, same example, same explanation is given here. One end behaves as a north pole and other end behaves like a south pole of a like a bar magnet. So that's why solenoid behaves as a bar magnet. So definitely both A and R are true, and R is the correct explanation. So option A is the correct answer. Now let's move on to the next part, that is section B, 2-marker question. Okay, state the phenomena observed in the above diagram. Explain with the reference to the diagram which of the two lights mentioned above will have the higher wavelength. Okay, now how we will, or there is a or question. This is a 2-marker question, so this is a or question. How will you use the two identical prisms so that a narrow beam of white light incident on the one prism emerges out of the second prism as white light? Draw the diagram. So this is also common question. Okay, just study diagram for 2 marks. First question, first of all, you have to remember that this is not red light, this is yellow light, and this is not violet light, this is blue light. So they have taken two intermediate lights, okay, and then based on that they have drawn this diagram. Now let's see. Dispersion. What is dispersion? Dispersion is the splitting of white light into 7. Okay, there was a question, I think. State the phenomena observed in the above diagram. So state the phenomena. The phenomena observed in this diagram is obviously dispersion, right? And the explanation is that splitting of white light into 7 colors on passing through a prism is called dispersion. That is the thing. Now velocity is directly proportional to wavelength. Now I don't know if you remember the formula in the form of V is equal to n lambda. I think you have learned it in your previous class, right? Velocity of a wave and lambda is the wavelength of the wave. So velocity and wave are directly proportional. N is the frequency of the wave. Okay, so V is equal to n lambda. Some book use it F frequency, but I like to use N. V is equal to n lambda. N is the frequency, lambda is the wavelength. Okay, V is the velocity. So velocity is basically directly proportional to lambda. Okay, so yellow light will have a greater wavelength than blue light, as the velocity of yellow light is greater than blue. Now how do we know that velocity of yellow light is greater than blue light? Okay, so from here you can see that the yellow light is scattering less compared to the blue light. Blue light is bending more. So whoever is bending more, that means he has a smaller frequency, higher frequency, less wavelength. Okay, you have to remember that whoever is bending more, they will have a higher wavelength, whereas whoever is bending less, they will have a this will have a higher wavelength, and this will have a lower wavelength. Okay, you have to remember that. Okay, so blue light will have a lower wavelength, yellow light will have a higher wavelength, because it is bending less, that means higher velocity means higher wavelength. So whoever is bending more, they will have a lower velocity, that means they will have a lower wavelength, right? You have to remember that. So yellow light, or you can just remember that yellow light has higher velocity, so it will have a greater wavelength than blue. Okay, so this is the answer, as easy as that. And if you are not able to answer that, then you have to answer that angle of deflection of two prisms needs to be equal and opposite. While the first prism splits the light into 7 colors due to different angles, the deflection of the second prism combines the spectrum among the single ray and color again combine to give the white light as emergent light. For this writing 1 mark, and for drawing this diagram you get another 1 mark. Okay, so this is the diagram. You know that the white light is traveling, then first prism is splitting into red, violet, other colors are in between, then the second prism is combining them, and again you are getting the white light. You have to practice this diagram. I would prefer this question over this question, because this question is slightly tricky and lot of practice is required, but this is also easy, not super difficult. Many students make mistakes while drawing this part of the diagram. Okay, be careful while drawing this part. Okay, now next question is section is 3 marker question. So let's see 3 marker question from physics. Okay, Rohit wants to have an erect image of an object using a converging mirror. So what is a converging mirror? Converging mirror, there is only one converging mirror. Basically that means concave mirror, sorry. Concave mirror is converging and convex lens is converging. Okay, they are opposite. So when they are distributing, that says that okay, mirror part concave you take, lens part I will take. Okay, so they have equally distributed among themselves. So whatever concave mirror is doing, similar things are being done by convex lens. Okay, and whatever convex mirror is doing, similar things are done by concave lens. Sorry. Now specify the range of the distance where the object can be placed in front of the mirror. Justify. So I remember I have solved a similar question in my regular classes, if you have seen them. Okay, so the range is basically given by when you are saying that you want a erect image by a converging mirror. That means converging mirror or converging lens, whatever it is, they produce erect image. Erect image means it has to be a virtual image. Okay, so erect image means means it has to be a virtual image. So that means the distance has to be less than the focal length. So this is the focus. So distance should be, maximum distance object can have is from 0 to within the focal length. Okay, this is the optical center. From the optical center till the focus, you can keep the object to get a erect image, right? So the distance range, we will see that in a while, but it is the correct answer. Draw a ray diagram to show the image formation. In this case, you have to draw the ray diagram as well. State one use of the mirror based on the above kind of image formation. One application is also there. Okay, let's see the answer. So the object must be placed at a distance between 0 and 40 centimeter. This is because image is virtual, erect and magnified when the object is placed between F and P. So for that you will get 1 mark. Okay, and for drawing this ray diagram, again, as I said, image distance has to be less than focal length, so it will be within focus, and you will get a virtual image which is erect. Okay, so erect image means this is called erect image, same side as the object, so that is why it is called erect, right? Used as shaving or used by dentist to enlarge image of the teeth. Okay, any one example is sufficient. Okay, it is used by the dentist to see the enlarged portion of the teeth. It is used by people as a shaving or a barber shop. Okay, they use the concave mirror to see the face a little bit larger. So that's why it is used in such places, right? Also in some cases, beauty makeup mirror of previous generation. Nowadays we don't use it, but when previous generation kings and queens used to make up, they used to use the concave mirror so that their face appears bigger, right? Now next question, a lens of focal length 5 centimeter is being used by Devashri in the laboratory as a magnifying glass. Her least distance of the distinct vision is 25 centimeter. Very, very important. Least distance of distinct vision is 25 centimeter. What is the magnification obtained by using the glass? Okay, focal length is 5 centimeter of the glass. So magnification, they are asking about what is the magnification obtained by using the glass. She keeps a book at a distance of 10 centimeter from her eyes and tries to read. She is unable to read. What is the reason for this? Another interesting question. Ravi kept a book at a distance of 10 centimeter from the eyes of his friend Hari. Hari is not able to read anything written on the book. Give reason for this. So this is also an important question. Similar question. These two questions are almost similar. Let's see the answer one by one. Given an image distance V is equal to minus 25 centimeter, focal length is 5 centimeter. So magnification M is, so they have calculated the magnification, which is turns out to be 6. Okay, so easy question. So for minimum distance of distinct vision means that is the distance from the that should be the distance from the eye to form the image. Okay, suppose you are reading it like this. Okay, so the image should come towards the eye from a distance of 25 centimeters so that you can see it. Okay, so this is the object distance, right? So object should appear from 25 centimeters. So you know that image distance is V equals to minus 25. This should be the minimum distance, right? Now using this minimum distance, focal length is given 5 centimeter. So you have to just find the object distance. Once you calculate the object distance, M is V by U. So you just need to calculate the magnification, which will come out to be 6. So obviously magnification is 6. Now why he is not able to see that? Because the least distance of the distinct vision is 25 centimeter. So least distance is 25 centimeter. That's why he is not able to see. Now the part 2 question answer is not given. Okay, part 2 questions is not given. Ravi kept a book at a distance of 10 centimeter from his eyes of the Hari. Hari is not able to read anything written on the eye. Give the reason for this. So Hari is not able to. Okay, 10 again same question. Okay, sorry. The both questions are same. I think this is an OR question. This is a OR question. Okay, these two questions are our questions. So she cannot see a book from at a distance of 10 centimeter. Why? Because the least distance of distinct vision is 25 centimeter. Even if your eyes are perfect, you need at least 25 centimeter from your eye to see things clearly. Okay, this varies from human to human slightly, but if you are reading too close to your eye is getting strained and your eyes will soon lose power and you will require glasses like me. But or if you are not studying in proper lighting conditions, then again your eyes might get damaged, so be careful. Okay, now this is not part of the lecture, there is just a suggestion to you. Now next question, 32. A student fixes white sheet of paper on a drawing board. He places a bar magnet in the center and sprinkles some iron filing uniformly around the bar magnet. Then he taps gently and observes that the iron filings arrange themselves in a certain pattern. Okay, why do the iron filings arrange themselves in a particular pattern? Iron filings are nothing but iron dust. Okay, many students don't understand what is the meaning of iron filing. Iron filings are nothing but iron dust. Okay, I don't know why they don't say iron dust. Maybe it's a term used for iron filings. Anyway, why do iron filing arrange themselves in a particular pattern? Which physical quantity indicated by the pattern of the field lines around the bar magnet? State any two properties of the magnetic field lines. A compass needle is placed near a current carrying wire. State your observation for the following case and give the reason for the same in each case. Magnitude of electric current, wire increased, the compass needle is displaced away from the wire. Let's see the answer. So first, when an iron filing is placed around the bar magnet, they behave like tiny magnets. Obviously, iron filings when they are in contact with the bar magnet, okay, they behave like a tiny magnets. Okay, and that tiny magnetism lasts as long as the bar magnet is there. If you remove the bar magnet, the magnetism is gone. Okay, the magnetic force experienced by these tiny magnets make them rotate and align themselves along the direction of field lines. So we know that field line starts from north, ends at south. So based on the how they are getting oriented, okay, they always orient themselves along the line of the magnetic field lines. Okay, now so that is why they form in a particular arrangement. So basically the iron filings represents the magnetic field lines. So for that you will get 1 mark. The physical property indicated by this arrangement is the magnetic field produced by the bar magnet. So basically they said that when a bar magnet is present, around the bar magnet, even if you are not looking, even if you are not watching, surrounding the bar magnet there is a magnetic field. So that magnetic field is represented by that iron filing. So that is the main thing. This represents the magnetic field. Magnetic field lines never intersect. Magnetic field lines are closed curves. So two properties of the magnetic field lines, that is also done, right? So they never intersect, they always form closed loop. Next, our question, the deflection in the compass needle increases as the magnetic field lines field current carrying conductor is directly proportional to the current flowing through it. So if you increase the current, the deflection will definitely increase because deflection is directly proportional to the current, right? Next is the deflection of the needle decreases as the magnetic field inversely proportional to the perpendicular distance from the wire. So as you move the needle away from the conductor, okay, it will decrease because it is inversely proportional to the distance. As the distance increases, the deflection also decreases. Now 5 marker question. The 5 marker question is in this paper is slightly tricky. They have given some 1, 2, 3, 4, 5, 6 different values, but don't get afraid with this. Okay, so they have shown a house, okay, from the top. So different rooms, suppose this is your drawing room, this is your sitting room, okay, this is your study room, this is your parents room, this is kitchen, this is your bathroom, like that. So this is, they have shown some house arrangement. Okay, and they have said that what is that? The diagram above is a schematic diagram. Now this kind of question is very common in case based question as well. Okay, so case based question and 5 mark question in this question paper, even the 3 mark question as well, they are all very much like same. Okay, there is no super difference between a case based question and long answer type question. Okay, now let's see. The diagram above is a schematic diagram of a household circuit. The house shown in the above diagram has 5 usable spaces where the electrical connections are made. So 5 usable spaces, as I said, one of them is drawing room, one of them is sitting room, one of them is drawing room, study room, bedroom, like that, right? Now, for this house, the mains have a voltage of 220 volts. So supply is 220 volt and the current coming from the main is 22 ampere. So current from the main is 22 ampere. What is the mode of the connection to all the spaces in the house from the mains? So what type of connection we use in our household circuit? What type of connection we use? We use parallel connection, right? So parallel connection must be the answer. So all the house, so basically you can replace this entire thing with 5 resistors connected in parallel. 5 resistors connected in parallel, one by one. Okay, I am running out of space. 5 resistors connected in parallel with a battery, and battery of 220 volt, and it is giving you a current of say 5 ampere, 22 ampere, right? So we will see that in a while. Don't worry, we'll solve the problem. This spaces 5 and 4 have the same resistance. So 5 and 4, so this is 5, say this is 5, this is 4, so they have the same resistance. Okay, you have to take the resistance to be some unknown value. If it was a mathematics, you would have taken that unknown value to be x. Since this is physics and we are a little smarter than, so we will assume that the resistance is r. We know that based on the problem, based on the variable that is given, we have to choose different symbols for that. So in this case, because it's a resistance and resistance is represented by symbol r, so we will choose r. If it is a mathematics, you just any unknown quantity, what do you assume? You generally assume x, right? So this is, instead of x, we will assume r. Same problem. Okay, so all the resistances are the same, so we assume these two resistances are r, and the same resistance and the space 2 and 3 and 2 have the respective resistances 20 ohm and 30 ohm. So 2 and 3 and 2 have respective resistances of 20 and 30. So this is 20, this is 30. These two we have assumed r and r. Okay, and the fifth one, space 1 has a resistance double that of space 5. So space 1 has resistance double that of 5, that means 2r. Okay, clear, all these resistances are connected in parallel. Okay, what is the net resistance? What is the net resistance for space 5? So space 5 you have to find the net resistance. What is the current in space 3? Another interesting thing, what should be placed between the main connection and the rest of the house electrical appliance to save them from the accidental high electric current? Another interesting question. Let's see the answer. This is a little longer question, 5-mark question obviously. So first, all spaces are connected in parallel. As I said, household connections are always done in parallel, no matter what. So if you write this, you will get 1 mark. Very easy, only 1 mark for 1 line answer, right? Let the resistance of space 5 and 4 be r ohms, respectively. Resistance of 1 is 2r ohms, resistance of space 2 is 30 ohms, resistance of space 3 is 20 ohms. So these are already known. Current in the circuit is 22 ampere, voltage is 220 volt, and what is the total resistance? Now this is the main part. So what is the total resistance of this combination, right? That is what we are trying to find. So 5 resistances, I said 5 resistances are connected one by one. Five resistances are connected to a 220 volt supply, and the current in the mains is 22 ampere. Right, so 22 ampere, this is R, 20, 30, 2R, right? So this is the connection. Now what is the total resistance? Total resistance must be, suppose I delete all the resistance, I just add say only one single resistance. So that is the equivalent resistance, right? So if we add a equivalent resistance, right, so what will be the value of equivalent resistance? So Req. So what is the meaning of this? Meaning of this means this voltage will remain same, the current will also remain same, right? So these two things will remain same. So R equivalent from Ohm's law, V is equal to IR, V is equal to IREQ. So Req is equal to V by I. Now what is V? V is 220 volt, I is 22, so basically it means 10 ohm. So entire equivalent resistance of all the resistance is basically 10 ohm. Now what is the equivalent resistance of all the resistances? That is, they are connected in parallel, so we just need to put the same value here and we will know that R equivalent is 10 ohm. Right, and after adding all the values, simplifying everything, you will get R is equal to 150 ohm. But that is not the answer. If you remember, they asked you what is the resistance of the space 5. Now space 5 is basically equals to, so what is the resistance of space 5? Space 5 has resistance R. So space 5, yes, done. Okay, if they ask you resistance for space 1, then you have to find resistance for space 1 was R1 equals to 2R, so that would be 300 ohm. Right, but since they have asked you to find the resistance of space 5 only, so you can simply say, okay, that is 150 ohm. Okay, simplification is required. I am not doing the simplification. Mathematics is common, only concept that you need to understand. Mathematics you have to try on your own and practice. Me doing mathematics will not help you by much. You have to practice the mathematics on your own. Okay, try to check this mathematics if you can solve it on your own or not, and you get this value or not. Okay, so 2 marks for this entire solution. Okay, now what else? Current in space 3 is very important. Current in space 3 is basically I3. I3 is V by R3. They are all connected in parallel combination. So we know that in parallel combination, voltage across all the resistances are same. So voltage across R3 should definitely be V by R3. So that is 220 divided by 20, that is 11 ampere. So 11 ampere is current in space 3. Easy question. So even though the circuit, the diagram looks complicated, it is actually an easy answerable question. To protect the house electrical appliances from the accidental high electric supply and electrical fuse should be placed between the main connection and the rest. So the answer is electrical fuse. Okay, you can highlight it. You can highlight this part, electrical fuse must be used. Right, this is the answer for the question. Now 4 marker question, again another diagram based question. So here, have you seen this? This is called a slide projector. Okay, this is a slide projector. The above images that are specialized slide projector slides are small, transparent, is mounted sturdy frames identically suited to magnification and projection. Since they have a very high resolution and high image quality, these are the tray where the slides are to be put into a particular orientation so that the viewers can see the enlarged direct images of the transparent slides. This means that the slides will have to be inserted upside down in the projector tray. To show her students the images of insects that she investigated in the lab, Mrs. Iyer bought slide projector. Her slide projector produced a 500 times enlarged and inverted image of a slide of screen 10 meter away. So enlargement is 500 and the distance is 10 meter. Okay, now let's see the question. Based on the text and the data given in the above paragraph, what kind of lens must be the slide projector have? So it is producing a real image and it is producing an erect image. Now how can a slide projector produce real and erect image? We always know that only the one lens can produce a real image, that is convex lens. Now how can you produce erect image? So to produce erect image, what you have to do, you have to invert the object itself. Okay, if you invert the slide itself, then the image will be inverted, double inverted, that means it will be an erect. Right, so definitely the lens will be a convex lens. Okay, if V is the symbol used for the image distance and U for the object distance, then with one reason state what will be the sign for V by U in the given case. A slide projector has a convex lens with a focal length of, so now in the part C they are already giving you the answer. So this is the beauty of this kind of questions. They are already said that they are using convex lens. Slide projector uses convex lens. So even if you have not you don't know the answer for part 1, you can answer it by reading the question. So always read the question before answering. Okay, with a focal length of 20 centimeter, the slide is placed upside down 21 centimeter from the lens. How far away should the screen be placed from the slide projector's lens so that the slide is in focus? Okay, when the slide is placed 15 centimeter behind the lens, this is the OR question, behind the lens projector, an image formed 3 meter in front of the lens. If the focal length of the lens is 14 centimeter, draw a diagram to show the formation, not to the scale. So this is a diagram, this is a numerical question, and rest two are the explanatory question. Let's see the answer for this. So obviously we use convex lens. As I said, convex lens is used because this is a real image. Only one lens can produce real image, which is a convex lens, right? Now what is the magnification sign for the magnification? They have not mentioned magnification, they have mentioned V by U. Okay, negative as the image is real and inverted, right? Even though the final image is erect, okay, the object itself is inverted, that's why the final image is inverted, right? So in this case, generally what we do, we draw a ray diagram like this. So in this case the object is inverted, that's why the image is erect. Okay, now you have to calculate the V in the given case. So 1 by F is equal to 1 by 20 and V is given 1 by 20. You have to calculate, put the values. 1 by 20 is the focal length, and some mistakes has been done, some calculation error. Let me see the question once more. The slide projector has a convex lens of focal length of 20 centimeter. The slide is placed upside down 21 centimeter from the lens. Okay. So U is 21. U is so it will be 1 by 20, that is F equals to 1 by V minus lens, right? So minus 1 by 21. This is the formula, right? So this will become plus. So it will be 1 by V equals to 1 by 20 minus 1 by 21. So the LCM is 420. So it will be 21 minus 20, that is 1 by 420. So don't do 420. Okay, V is equal to 420 centimeter. Okay, so this is the answer for this question. And for the second part, obviously you have to draw the diagram, which is very simple. The object is below focus, behind focus. Okay, obviously if it is closer than focus, then it will be a real erect and virtual image. So it is producing a real image. So this is how it is produced, right? In older generation, when we used to visit theaters, okay, they used to have films, okay, and it is being projected using projector cameras, film projectors. Okay, so they used to have two different cameras and two different projectors, and the reel was rotating. Now in that reel, the reel was installed inverted, so that after the actual image is getting inverted, we see the erect image. Okay, so if you see the film which is going through the projector, it is going in the upside down, so that when we are seeing it in the screen, it is not only magnified, it is also appearing upright, right? So that is a trick I teach you, right? Now if you have liked our channel, don't forget to subscribe it, share it with your friends, and bring more and more students to the channel so that we can grow together and learn together.